Okay, let's begin. So last time we talked about the inverse sine and inverse cosine. And we have two ways to denote the inverse sine and cosine. One is the inverse sine of x. And this is same as arc sine. Okay. They are same thing. So just two ways to denote the same inverse function. And similarly, you have the inverse cosine, which is same as the arc cosine. Okay. And when you define the inverse sine and the inverse cosine, you must watch out the range of these two inverse functions. So we know the inverse, okay, the range of inverse sine is the closed interval from negative half pi to half pi. So some guys ask me why the inverse sine of the negative root of 2 over 2 is not equal to 7 pi over 4. We know 7 pi over 4 its sine is really equal to negative root of 2 over 2. But the 7 pi over 4 is not in this range, right? When you take the function value, your function value must be in the range of this function. So this guy, 7 pi over 4, is not in this range, so it cannot be the function value of the inverse sine of the negative root of 2 over 2. And the right answer for this one is inverse sine of the negative root of 2 over 2. We know the angle which is in this closed interval and whose sine is equal to the negative root of 2 over 2 is equal to the negative pi over 4. And this is right answer, not the 7 pi over 4. Okay. Similarly, the sine inverse of 1/2, this one is not equal to 5 pi over 6, although sine of 5 pi over 6 is really equal to 1/2. But this 5 pi over 6 is not in this range, right? So it cannot be equal to the function value of this inverse sine of the 1/2. So the right answer, inverse sine of the 1/2 is equal to pi over 6, because we have the sine of the pi over 6 equal to 1/2, and also this pi over 6 belongs to this interval from the negative 1/2 and 1/2. By the one-to-one correspondence of this invertible function, we know we can only have one angle, pi over 6, for which the sine is equal to 1/2. And similarly, for the cosine, for the inverse cosine, the range of the inverse cosine of x is equal to the closed interval from 0 to pi, which is different from the range of the inverse sine, right? So you need to watch out for this. So therefore, we have the inverse cosine of the negative root of 3 over 2. This one, okay, is equal to 5 pi over 6, because we have the cosine of the 5 pi over 6 equal to negative root of 3 over 2, and also 5 pi over 6 belongs to this range. Okay? And one question is about the range of the cosecant function. We know cosecant is equal to 1 over the sine, right? Okay, and the sine, okay, we know its absolute value is less than or equal to 1. So that means this y is absolute value, which is equal to 1 over the absolute value of sine of the 3x plus pi is greater than or equal to 1. Right? You divide both sides by this absolute value. From here, you just get the 1 less than or equal to 1 over the absolute value of the sine of the 3x plus pi. Right. So now you just get this inequality involving the absolute value. So you have the absolute value of y greater than or equal to 1. And we know how to solve this simple inequality involving the absolute value. This just implies either you have y greater than or equal to 1, or you have the y less than or equal to negative 1. So the solution set for this inequality S, that should be the set of the y such that y either greater than or equal to 1 or y less than or equal to negative 1. If we use the interval notation, then this should be equal to the union of these two intervals, either from the negative infinity to negative 1 union the interval from 1 to infinity. Let's continue to talk about the inverse functions of the tangent, cotangent, secant, and cosecant. So for these four functions, we just do them in a fast way.